Welcome everybody. Apologies for the delay. We've had some gremlins in the system, but I think we've worked through the technical difficulties, so thank you for bearing with us, and we apologise for starting a little bit late, but what can you do? We're all here, and this is good. This is post-COVID, we're improvising. It's all going to be good, and we're going to enjoy today's wonderful research seminar with our very special guest from Germany. So to kick things off, I want to welcome you to the Monash Sustainable Development Institute Research Seminar Series. This might be the last one for the year. I'm Darren Sharp. I'm a Senior Research Fellow here at MSDI. I'd like to begin by acknowledging the traditional owners of the lands on which we meet today, the people of the Kulin Nation, and pay my respects to elders past and present, and extend that welcome to any Indigenous people joining us today. So today we're very excited and very pleased to hear from Claas, Digmayer and Yannick Schöpper from RWTH Aachen University for their talk titled Towards Niche Readiness, Achieving Socio-Economic Maturity in the Bottom-Up Transition to DC Power Systems. It's a great pleasure to have Claas and Yannick join us all the way from Germany, and we had some really good time together last week at the International Sustainability Transitions Conference. So I've got to know them a bit better. We've been speaking for about a year now online and been very much looking forward to welcoming them to Monash. And I'll just say a very brief bio about the guys and just remind you of the format for today. So we'll have about a 25-minute presentation, and then I'll facilitate a moderated Q&A with the audience here in person and on Zoom. So we should have about an hour session, and we're happy to go a little bit longer because we started a bit late. So just very quickly to introduce our guest, Claas Digmayer. Dr. Claas Digmayer is a research associate at the Human-Computer Interaction Center at RWTH Aachen University in Germany. He graduated in technical communication and computer science at Aachen University, and his research interests include the design of digital platforms with regard to usability and UX, the analysis of big data with text mining and AI methods, and innovation methods, including design thinking and open innovation. The CP. And Yannick Schöpper is joining us as well. He's a researcher at the Human Technology Center at RWTH Aachen University, and he received his MA in political science from Bielefeld. I'm sorry if I mispronounced that university. And was that correct? Oh, that was a good guess. And he's currently a PhD student at RWTH. His dissertation focuses on the development of renewable energy policies in Germany and the United Kingdom, and his research interests lie in the fields of policy analysis, comparative politics, and transition research, with a focus on German and European energy policy, and in particular, the promotion of renewable energies. So without further ado, please join me in welcoming Claas and Yannick, and over to you guys. Thank you. Thank you.
Yeah, thanks for the introduction, Darren. It's nice to have the opportunity to hold a presentation here about our wonderful research project, which is called FEN, Flexible Electrical Networks, and actually it's a research campus. So we have also sister projects that are more dealing with the technical aspects of DC technologies. What DC technologies basically are, I will tell you that a few slides later. Just to for an introduction, you see our buildings here at Aachen. This one is the FEN building, and the other building is basically for our electrical engineers. It's called Carl building, and was set up recently last year. So the program for today is that I will give you a very brief introduction what DC technologies, so direct current technologies are, very basically, and then we get to the conceptual work that we do within our project, and Claas especially is then addressing the empirical question of social mechanisms. So, and we would like to have a discussion at the end or after our presentation about this conceptual work on the one side and the social mechanisms on the other side. So our topic is the diffusion of direct current technologies, and this here is basically the technical difference. As you see here, you have like the same voltage with direct current technologies, and you have this zero crossing here with AC technologies, and it's missing with direct current technologies. So just please don't ask me more about this because I'm not an electrical engineer, but this very basic, on a very basic level, the technical difference here. And as you might have heard, there was the war of the currents that took place end of the 19th century.
Sorry, guys.
Okay.
Let me get out of here. Sorry.
Oh, yeah. My apologies. So, yeah, no problem at all. And as you might have heard, the winner, so to speak, was AC, pushed forward by Westinghouse, and the loser, in a kind, Edison and the DC technologies. And the key argument back then was the long distance transport of electrical energy, because it was not possible technically to have a long distance transport via DC direct current technologies. So, and with AC, it was possible back then. And this led then to the development of AC grids and a very, very large AC infrastructure that we have today. And due to different developments in especially semiconductor technologies, the key arguments might have changed. This is basically the issue or the problem we're addressing in the research project. What to do with the AC infrastructure if we have now a energy system that has changed as a whole, and if we have now DC technologies that offer new opportunities and inhibit new advantages, like, for example, energy efficiency. I will show you an example one slide later. So it is about energy efficiency, it's about the cost saving, and it's about the higher flexibility on the grid level. We will not address this in detail in this presentation, but especially when it comes to the distribution grids, DC offers very much advantages as it makes grid operation far easier than with AC. And with the integration of renewables comes the decentralization of the grid. So we have the problem in several countries, in Germany as well as in Australia, that the distribution grids are already kind of overloaded. And we have to rethink maybe our grid structures. And as we have to invest much money in the future, it might be an opportunity to think twice here. So to rebuild or to enlarge the existing infrastructure with AC solutions, or to have a DC solution here. And to give you an example, today in our home, we might have this situation, or we might have that in the future in many homes, so that you have solar on the rooftop that is producing DC, and then it's converted by a rectifier to AC. And then it goes through an AC cable to a battery storage that runs on DC. So you have the next conversion here. And then when you use the energy, the storage energy, then again it's converted to AC, and then it runs via AC cable to a consumer, which is basically, or which could be a laptop, an electric vehicle, a TV, or an LED, or whatever. And these devices, these users, are all running on DC. So why should we have AC cables at home at all? So you see, every conversion means a lot of energy here, and we think this argument might show that AC that it's not maybe the best option nowadays to have a fully AC grid in our homes, so to speak. And now we are addressing the conceptual work we are doing in our research project. So here you see our different work packages. I'm taking care of work package 2. It's about the governance aspect, so about the regulation and which stakeholders are involved within the development of DC technologies. And we have also economists on board. They cannot be here in Australia, but they are in Germany as well as our partners from industrial engineering and ergonomics and all the other work packages. are here in this room together with me, and are dealing with various issues like landscape planning, urban design, and acceptance researchers. All of these realms are relevant to the niche development, to the overall niche development for DC technologies. And you're very familiar, of course, with the multi-level perspectives and strategic niche management as part of our conceptual framework. This is what we like to discuss with you today. Mainly, is this here. In the project, we want to develop a so-called niche readiness level model, and you don't have such a model so far, so it's kind of missing in the current research. And on the next slide, I'd like to address the benefits of such a model. So I'm presenting today work in progress. The model is not yet finished, but we can address and can discuss with you why we need such a model and what could be the benefits of this model. And one benefit might be the visibility. So it makes a difference if you mark the niche as a niche, because I believe many stakeholders involved in the development of DC technologies are not aware of being part of a niche that is developing around DC technologies. And this is what you have here in the technology readiness level model, developed by Mankins and others, and especially by the NASA. And so this was very inspiring for our project work to have a diffusion of this idea to the concept of niches. So if it works on a technical level only, why shouldn't it work on a niche level that is also addressing the social aspects that go along with niche development? And basically, you see that with such a model, you could then raise awareness what niches are, and you could offer this as a tool for practitioners. Like, this is also a tool for practitioners. And to give you one example, just recently, has been, I think, 2 months ago, we received a call from a manufacturer of rectifiers for solar panels, and they asked us, Claas and me, what the niche readiness level of DC technology is actually. So what we could tell them about the current development of DC technologies and what our opinion on the overall niche development is. And I believe they expected an answer like, okay, we have now reached niche readiness level 9 or 7 or whatever. We couldn't tell them, so they were kind of like disappointed. But it shows the interest of the industry. So, and it shows that that it makes sense to offer such a tool for practitioners.
I think we should also add that these were the guys from the innovation department from that company. So they were kind of supposed to know about this. But that shows that being aware of the visibility in niche is really important.
Yeah, definitely. And this is the next benefit here. So it's the contextualization and sensibility for differences. Because I have talked about DC technologies in general so far, but as you can see here, unfortunately it's in German, sorry, you can see here the range of different DC technologies and the range of different contexts where to deploy DC technologies. So it can be used in buildings, so then about DC cables, but it can be also relevant to the generation of energy and to the transport of energy. So, and it makes a difference if you have a look upon the grid development or the grid management or whatever, or if you take into account a DC building, a DC neighborhood, what else? And basically, these two here are use cases in the project: DC buildings and DC neighborhoods. And therefore, we need different disciplinary lenses, of course, because the contexts are so complex that we couldn't cover them with just one disciplinary lens. We need more of them, because grid development, of course, has many spatial aspects. So how to organize it, or it also refers to the acceptance of technologies. And of course, it's a matter of regulation, because we have this revenue cap regulation scheme in Germany, and it's, I believe you have the same in Australia. And this does not really give the grid operators much incentives to have innovations in their grid development. So this, of course, also a problem. And to address these very different contexts, we need interdisciplinary work. And of course, then it's more about conceptual rather than statistical questions. And yeah, the third realm of benefits is referring to social mechanisms. Claas, will you tell more about these mechanisms and which mechanisms we have identified so far in the field? And we believe that these mechanisms, or the social science concept of social mechanisms, inhibits very many advantages for our research project. First of all, it is addressing these fuzzy relations we have in the field. I know, or I can imagine that everyone who's familiar with transition research is facing also these fuzzy relations, and we are trying to via social mechanisms, we are trying to reduce this fuzziness by linking in and outputs. So make it very clear that you have not these fuzzy relations or other concepts, but just only these social mechanisms. And it performs very well in combination with middle range theories, like the multi-level perspective, strategic niche management, small n analysis, which is really important for us, because there is not so much empirical information so far in the field, because DC development is not so far at this stage. It also is combinable with a case study design and different types of modeling, because our economists also use this agent-based modeling here. And there was a very good text from Frank Geert from this year, 2022, on this matter, and he's really stating this year and making clear that these are advantages that go along with the social mechanisms approach. And of course, it's a kind of explanatory middle way. So it's context sensitive. It's between nomothetic and ideographic sciences. And therefore, we have to take into account these different contexts. And as I showed you before on the slide before, it's very, for us, it's very crucial and important to have this context sensitivity here. So it matches our requests we have. And then, last but not least, it has a character of a boundary object that allows interdisciplinary research. This is also a advantage of the concept of social mechanisms. And then I'd like to hand over to Claas.
Thank you. Okay, so please keep in mind this is our preliminary, these are our preliminary results. So we identified 5 mechanisms. I'm going to talk about these in detail in the next minutes. But first of all, just to give you an impression, how did we arrive at these, or how did we discover or derive these mechanisms? As Yannick already told you, our project is quite interdisciplinary. So it's really a broad mix of different methods that we use. For instance, qualitative methods such as expert interviews and workshops, and also quantitative methods such as simulation studies, like our colleagues from the economics conduct. And these result in a vast range of different data sets. And we also have some exchange formats, so that we try to get in dialogue with colleagues and experts from the field. For instance, our colleagues Rafaela and Sarah were really successful in acquiring funding for a format that is called a pop-up campus, and that is kind of an experimental space where new innovative constructional approaches can be tested. And that is also linked to a lecture series where experts from the field discuss about these topics. And also we have research internship and visits. I spent the last 3 months in Texas to examine energy communities for the PEN project. So there's really a broad range of data sets, and what we do, or why we do this, is we like to cover a broad range of perspectives, because the problem, especially in the energy sector, that you will have a hard time finding two niches that are exactly the same in terms of the object or the technologies that are developed, the stakeholders, the project goals, and so on. So that this is one slide that shows a case study that has been conducted by our colleagues from the work sciences in work package 4. And you can see here that it's only a very a complex slide, but the main takeaway here is that there are really different things that are investigated in these projects. For instance, like PV and wind turbines, charging for electric vehicles, and also business models. So this is really different topics and technologies that are focused on. And they did a great job in just trying to categorize the different niche actors that are involved in the niche development. For instance, the industry, for the energy sector, especially the energy industry, research, academia, of course, the customers, and what is really perfectly visible here, politics, administration, authorities, such as funding bodies.
English this year. Huh? Check out my Zoom.
Just getting some background.
I've only done one page.
Craig, maybe if you want to mute your mic, Craig, if you can hear us.
Okay. So any questions, we can let's discuss them later on. But here we can see that there are also the funding bodies, such as the German Federal Ministry of Education and Research, which is funding our project, which I'm really thankful for. But as you can see here, there are really different actors and stakeholders in this project development, and we try to incorporate as much as possible all of these different perspectives in our work. So with so much talk about our methods, now I'm quickly going to talk about how we try to combine all of these different data sets and perspectives that we have. So this is, of course, exciting on the one hand, but also challenging on the other hand. And so what we are doing is we take a ground theory approach. We try to develop or make conscious decisions which phenomena we would like to investigate. And so we build our categories and also these social mechanisms inductively from the material that we have. But also we are not trying to reinvent niche theory. So we also take deductive categories that are already existing within the literature, not literacy, sorry. So with so much talk, I'm now going to take the next 5 minutes to talk a little bit about the mechanisms that we have. So the first one is called framing, and that is used to link technologies to certain attributes. And this requires, of course, that these attributes need to be selected and make salient in the communication efforts. And this allows different problem diagnosis and proposed solutions. And an example for this would be like here in a citation from one of our expert interviews. And this person said, okay, an important point is really energy efficiency. And that is one of the main frames that is used within the technology or the field of technology. But this frame is not sufficient to convince stakeholders from the other fields. So what is missing here is a frame such as sustainability or maybe the broader societal consequences of these technologies. The next frame is exploration, and here the problem is that local projects are taking place in niches, so in protected spaces. which are protected from market pressures. But these projects are in most cases only partly protected, and that means that there are already regulations and rules that these projects have to adhere to. For instance, there are not so many regulations for DC technologies in Germany, but a lot of regulations for AC technologies. And the DC technologies have to adhere to these rules and regulations. And then the problem is that these regulations are not really fitting for DC. So it requires developing coping strategies. We found that the projects are really creative in developing these strategies. So they partly try to ignore these rules or really are creative in reinterpreting how these rules can be applied. And doing this allows that the project actually can progress in a certain way. And here again, we have a citation from one of our interviews. And this person said, okay, I'm in a dispute about a project where DC is involved, and actually the grid operator says, we're not really allowed to connect you, and if you do that, we have to charge you double. So that shows some of the challenges the projects are dealing with. The third mechanism is standardization, and here the problem is that we need uniform rules and procedures. That is somehow also connected to the mechanism I introduced before. And here the problem is that there are not so many rules and procedures for DC. And developing these rules and procedures requires assumptions about the adequate configurations that is agreeable for a lot of stakeholders. And this allows in the end that there are conventional solutions for common problems. It's a bit complex, maybe, but we can illustrate this again with a citation. Here, one of the experts said, okay, we are lacking standards for DC, and that's not only a lack of standardization for the technical design, so for the components, but also for the processes, for the planning processes, installation processes. And this is a killer argument because that really can lead to problems if the new technology is supposed to enter the market. Okay. The next social mechanism is acceptance, and here the problem is that is also linked to the framing mechanism, that we need to convince different stakeholders about these technologies and the projects that we are involved in. And this requires identifying the right aspects, because stakeholders do not evaluate technology as a whole, but certain aspects. And which aspects are evaluated depends on the stakeholder. So selecting the right aspects and communicating these is really important to facilitate acceptance. And this allows, in the end, attracting stakeholders to the niche development and also mitigating resistance, especially from the authorities. Of course, we have a citation here to illustrate this. Here it is said that from the perspective of customers, so if buildings are constructed and these people who say, okay, we would like to buy a new house, mostly the perspective or the most convincing argument is economic related. So these people are interested in, if we invest in DC, will it pay off, and how fast will it pay off? And they're not really interested in other arguments. So for instance, energy efficiency, like I said before. So that is really important to keep in mind. But this is only momentarily a snapshot of this acceptance, because that may can change in the future. Some experts told us that DC may become something like the new iPhone or the new Tesla in buildings, so that you can really be proud to own a building that is working on DC or running on DC technologies. Okay, I'm a little bit over the time already, but I'm going to talk about very briefly about the last mechanism, that is imitation. So the question is, does these local projects, but we would like to diffuse the technology or the experiences that we have made in these local projects. And one mechanism how this can be achieved is imitation, like you can see here the two graphs. So the problem here is really how can this be achieved? So we need assumptions about the prospects for success for these different technologies that we develop. And so there needs to be proof that these technologies can be deployed in other contexts. And this, in the end, leads to technologies being able to be scaled up in a global niche and also determine the development path of technology. The last citation for today is that is a citation from one of the grid operators we talked to. We found that they have a toolkit with standard solutions for common problems. And if DC is not part of this toolkit, so it will never be used to solve these common problems. And they told us, okay, we need proof that this is really working, that this is a reliable technology, and that is also the best or the cheapest possibility for a certain case. So, and if these arguments there's proof for these arguments, then DC could become part of this toolkit. Okay, so we've presented our approach, the first preliminary results, and would like to thank you for your attention. And also, we are really excited for your questions, and we would like to get maybe some feedback about our approach, the mechanisms, and get in discussion with you. Thanks.
So what to mention is that you can also ask our colleagues from the project, because Claas and I were just presented, but of course my colleagues are free to answer also incoming questions. So we have here the proof.
Fantastic. Thank you so much, Yannick and Claas. That was an excellent presentation. Very grateful for your time. I might just invite the group that's with us here in person to ask any questions or provide feedback, and I might just pass the microphone around. And when you do speak, if you could just introduce yourselves and say your name and where you're from, that'd be great. And I'm keeping an eye on Zoom as well, but because I'm not in front of the computer, if people would like to ask a question on Zoom, please just yell out and we will invite your questions too. So would anyone in the room here like to provide feedback, or does anyone have a question for Yannick and Claas? Megan?
Yep.
Maybe just in case, shove it.
Okay. So it's Megan Farrelly. I'm from the School of Social Sciences in the Faculty of Arts, and a part of the Net Zero project that you're here with and working with Darren and Rob and others. I really like the different kind of the mechanisms that have been identified, but I was curious as to some of the interrelationships that I see in the patterns between some of these ones. In particular, thinking about the one that you had there for standardization and also for imitation, in that I see that a lot of the pathways for imitation, so this idea of replication and diffusion, kind of build towards a greater understanding of achieving standardization such that you can meet the global regime or the global niche, sorry. So I was just wondering about some of the kind of relationships that you see that exist between each of these features. I mean, I know it's presented in this way for an easy communication device, and I liked the way and the use of the quotes, but I'm just, curious about some of these interrelationships and overlaps that might be there, because I think too, in relation to acceptance, it kind of sits in a different, I'm thinking linearly in that way in terms of where acceptance ends up. But I guess before we head to the acceptance question, I'd just be curious about the relationship, I guess, between imitation and standardization. Is that even on? Sorry.
I think it is. Yeah, it's very nice. Yeah.
That's actually a great question, because as Yannick mentioned, we started with this technology readiness model in mind, and somehow thought that the niche readiness model could look a bit like this, so that you have a sequence of stages, get from one stage to the next. Now we found that this is not really the case, so it's, I think it looks more like a network of different mechanisms that are also linked with each other. So framing as kind of a prerequisite for acceptance, for instance. And partly they overlap or have outputs that are used as inputs for other mechanisms. That's a perfect question, because we're trying to figure out how this actually could look like, that we have kind of a visualization just to make things easier to understand this and what how it looks like at the moment.
Yeah, I see that. But let me answer first, maybe, Stefan. Yeah, the question is if we have similar sequences when it comes to different technologies and different niche developments. So you could argue that standardization is a prerequisite for standardization. Standardization is a prerequisite for diffusion, but also you could argue the other way around, that you have cases where diffusion is the prerequisite of standardization. So what comes first? So we see that interlinkages here, and we believe that, for example, framing is in the very early stages a very relevant mechanism, because it is important for gaining resources for different trajectories, so to speak. And we see that when it comes to DC development, that we have a rather industrial and a non-industrial framing. So the industrial one is highlighting very much the energy efficiency, and you have very high efficiency gains when it comes to industrial production, the big machines and what you have there in the factories. But on the other side, we also have met people who said we deployed DC because we think it's an innovative approach, and it allows for more comfort, and it allows for energy sharing in a DC neighborhood project. So this is, this shows like how framing is at a very early stage, then defining the criteria for success or failure, basically. Stefan.
Yeah, and I would like to add to this question, which is really important for developing our thoughts further. It's about that we can say, well, in a perspective of sociology of knowledge, we have this institutionalization is then a form of standardization, because it's not creating social routines which are then familiar for all. And the very question here is now how these imitation as a starting point for in a specific context is going on, and then fueling processes of institutionalization, standardization, and then from there on new forms of imitation start. So you have somehow an acceleration process going on, because they are going into each other and then supporting each other of these mechanisms. So it's important to see that these mechanisms are highly related, and that that we have to see them in specifics or in relation to stages in processes. So that we analyze process related and how they are combined, or how they work, or how they are blocked, and therefore identifying possible windows of opportunity where to restart the process. So thank you very much. Important question.
I can see Rob, you have your hand up. Rob, would you like to ask a question? I don't know, my face just came up there. That was very strange. But hi, Rob. Welcome. Good to see you.
Hi everyone. I'm sorry I can't be there, but I'll be there this afternoon to say hi in person to you all. Really interesting presentation. Thanks for that. And I supervised a student about 4 years ago who looked into DC technologies, also using sort of multi-level perspective thinking and niche thinking to explore how that could then feed into sort of more traditional approaches to technology road mapping, which are traditionally not really looking in depth into all sorts of social processes. So really interesting stuff that you're presenting. One of the things that I wanted to bring in is whether it would make sense to talk plural. So understand niche is not a sort of a homogeneous singular thing, but actually that there are multiple niche applications where DC technology is applied and can be applied, and each of those might have different readiness levels. For instance, the student I mentioned, she looked at niches in public street lighting, greenhouse lighting, utility buildings, residencies, data centers, and so on. So she had like a list of 7 or 8 different application domains. And she assessed sort of momentum of each of those, also looking at sort of what are the kind of actors involved, how aligned are their expectations, to which degree have there already been actual pilot plans and demonstrations, and what kind of lessons are being drawn from those. So I wanted to throw that back to you and say, what's your thinking, or ask what's your thinking in terms of looking at a diverse set of niche applications, and maybe use that as a starting point to understand what the readiness level is for each of those. Thanks.
Yeah, who wants to answer? Stefan? Okay.
Yeah, thank you very much for this really important question, because we look at these niches as a network of niches. So that's an important point. Although in the presentation we focused on these mechanisms to make clear what is our conceptual framework, but if you look at the concrete phenomena in regard to these energy transitions, the interesting point, and that brings me to a really important question: now whether we can map such niches and their different readiness levels. So, and it's really important. Another point I would, or 2 points I would like to make, is that we start to think about these niche readiness level because it's about a transforming of an infrastructure, and therefore our analysis is going on to reconstruct and to construct at the same time new situations. So that's a really difficult methodological problem we would like to aim at with this kind of model. And the second point I would like to make here is that, as you mentioned, Rob, the point is what is going on in these niches. That's true. It's not about only one specific technology. It's about socio-technical configurations. And that's an interesting point that we would like to see and to classify which kind of socio-technical configurations creating a throughput situation so that a specific input is transformed in a specific output with regard to a transformation dynamic in relation to the transition of the energy system.
Yeah, that's very crucial. So it would be also my position to say that we have very different configurations, because one should make clear that you have certain realms where the development of DC technologies has yet ended or finalized, so to speak, especially in the high voltage sector. So if it's about this transmission lines that are newly erected in Germany and elsewhere, they are normally standard or DC as a standard option right now. And also what we talked about, this laptop here, this smartphone is already running on DC. So this is also labeled as a DC technology. And our task is to find out what are like new DC technologies and new configurations where different technologies, DC technologies are combined and are combined to have an added value at the end of the day. And the added value could be that energy sharing on a neighborhood level is made possible. The added value could be a gain of energy efficiency. The added value could be a higher rate of security, also a higher rate of freedom. It depends really on the configuration, and it depends on the actors and stakeholders involved in this very development here. And of course, as we told in our presentation, we have these very, very different contexts, reaching from the single building level, via the neighborhood level, maybe the city level, but that's not really part of our project. But of course, we have this low, medium voltage level on the grid level and the medium voltage grid. So very, very different contexts, very different configurations, and therefore very different stages of readiness to identify here.
I can see Craig has his hand up. Craig, would you like to ask a question?
Yeah, thanks for that. And I'm sorry for making all that noise before with my microphone on.
Okay.
This is a really great project, and it's almost surprising to me. My particular interest, I have 2 quick questions. My interest is in grid transformation, and in particular, the potential for a grid that doesn't target 99.998% reliability. And my reason for this is the internet model, where the smarts are at the nodes. So the internet doesn't try to be 100% reliable. That reliability is picked up at the nodes. And so I wonder if DC, the introduction of DC, could piggyback off of a different model for grid reliability, lower. So 98% reliable, for example, costs as less as half the grid cost than 99,998. And my second question is there anything to learn about socio-technological changes from Australia's conversion from 36 volts to 240 volts? So how was that carried out? How did that disperse across our country? Those are my questions. Thanks.
Regarding the reliability, our technical partners, I think, would be a little bit better suited to answer this question. But as far as we know, DC allows to really efficiently or at all connect different energy producers and consumers, and that would allow kind of decentralized energy production and consumption that would enable something like energy autarky, so that if the grid goes down and you have kind of an outage, that it's possible to have these local grids that use, for instance, solar energy and kind of battery storages, not only in particular houses, but like a community storage. And that would allow communities to still have energy left or use energy even if the whole grid is down. So DC is really a technology that could not really improve the overall grid, but allow these local grids really to be efficient and to be effective for reliability in these contexts. So I hope this answers your first question. And for the second question,
could you maybe re-specify your question? Did I get you right that there is a change in the voltage in Australia?
Yeah, I brought it up because it happened quite a long time ago, but it's an example of a large-scale socio-technological change, and it started at 36 volts. Yeah, and then the higher voltage, 240 volts, proliferated out. And so there would have been a social campaign that accompanied this. There would have been acceptance, replacement, the sort of things you might expect if we all switch to DC. But I take on board what you say about so many of our appliances already being DC based. But to me, it seems like a similar transition may have taken place in the past.
So I'm not really familiar with that change in voltage. That's why I can't really comment on that. But yeah, it's interesting that you mentioned that. So it might be an opportunity to learn from that example. But I fear that in comparison to the development of DC technologies, this might be a case of rather incremental change within a running system. Because, of course, you would need new components, new standards, and all of that. But in comparison to DC development, it's rather like an incremental change. But what we learned yesterday from an electrical engineer here from Monash University is that you face on the grid level serious problems in Australia, so that AC grids are overloaded. And we face similar problems in Germany. And suddenly, like in the middle of the meeting, he said, of course, if we would have built these grids in DC back then, we wouldn't have had a problem at all today. It's a matter of fact. So this is very surprising, and this shows like the scale and of the problem, and this shows also the scale of the path dependency here, because also research and innovation in electrical engineering is taking place on a rather incremental stage. So they are not like widening the scope to these paradigm shifting questions really. And this is also part of the problem, the missing knowledge.
And I would like to add one argument, because that's really an important point you put forward here. It's about these infrastructural changes. So that these infrastructures create specific environment and fix specific habits, technological constellations, and therefore it's really interesting whether and how some things are experimentalized. So also the idea of decentralize, as Claas mentioned, to decentralize and do it in DC. That's a really interesting thing, because at the beginning or at the end of the 19th century, the creating of the networks of power, as Thomas Hughes described it, it's about this stabilizing a system via centralization, and we now going back under the auspices of new technologies to stabilize via decentralization. So that's really interesting dynamic, but we have to be careful with regard to the specificities and the specific features of each of these socio-technical configurations. So because otherwise we do learn or come to false conclusions out of that. Yeah, thank you very much.
Hope this answers your question.
Are there any other questions from our Zoom audience? Craig's going to sum up, so that's a good sign. Anyone else online have a question or comment before we wrap up? Anyone else in the audience today here at NSCI have any further questions or comments? Hal?
Yeah,
I think the mic help.
Yeah, very quick one.
Sure, go.
Yeah, sorry. Yeah, I'm Hal Wang from the Faculty of IT and working in the space of sustainable energy, mostly in the technical stuff. But here, kind of curious about this acceptance. Say that, so kind of think about the other new technology, let's say quite a few years ago, like solar panels, that was quite successful, that people, kind of into it. And that was like a case that you can clearly demonstrate the economic benefit that you're going to save energy, not save energy, you can purchase less energy from the grid, that saves your electricity bill. And also, you can sell back into the grid and to make money. And the feed-in tariff was pretty high in the past, but certainly that decreased now. So in the DC case technology, have you got like a figure saying that, because you mentioned the economic benefit, right? Demonstrate that to the customers, and have you got any figures that how much economically customer can benefit from adopting DC technology, replacing from that, right? Because I think certainly that makes sense that in the picture that's showing DC and AC kind of mix used at home, and certainly that cause like efficiency issues and things like that. So just curious about this.
Yeah, thank you for your question. It's also really relevant, and the problem first for the acceptance part, it's energy is kind of it's invisible. So for most customers, it doesn't really matter if it's AC or DC that's coming off your power plug, and so it's also really difficult to talk about this. And in most cases, it's not about energy, but about energy services. So in most cases, you'll find out that there's people are interested in energy if it's not working. So if you have an outage, then the discussion starts. So, and this is usually, as we're now facing these problems in Germany, could be a starting point for the discussion. And the second problem is that it's really because there are so many different technological configurations with DC, often a bit difficult to show the particular advantages precisely. Our colleagues from the economics did one study on microgrids in households and found that it really differs. But they found that, if I remember correctly, there are potential cost savings that range, depending on the configuration, from 30 euros. I think that's about, in Australian dollar, $50, and up to, I think, 190 euros per year. So really a great difference. But if you have a look now, the energy prices really go up, and this could be also an argument for cost savings that could convince customers.
Yeah, and it's just to add briefly on that, it's also depending on the price of copper, because for DC cables you need less copper,
And so if you have a very high uprise in the copper prices, you gain, of course, attractiveness here in the economic realm when it comes to the cables alone. So these surveys our colleagues made from the economical department of the FEN project, within the FEN project, these might be different with a different copper price. So yeah, it's a very crucial factor here.
Hope this answers the question.
Thank you. Right. I think we've pretty much come to the end of the session today. I'd like to again thank Claas and Yannick so much for joining us today, and for the whole RWTH Aachen team for being here. It's a real pleasure to have you. Look forward to future MSDI research seminars in the new year, and thank you to the online audience for joining as well. And please take down their details and follow their research. They're working on some really important projects, really ambitious, and so it's really a pleasure to have you here and to learn more about your work. So please join me in thanking everyone for coming.